You just did the most ordinary thing in the modern world. You typed 6 letters into a box and pressed enter. Inside the next 0.2 of a second, your computer is going to wake up roughly a dozen pieces of infrastructure spread across 4 continents. It is going to ask permission, exchange secret keys, route a question through machines you do not own, and receive an answer assembled by computers that have already finished thinking by the time you finish blinking. And then it draws a white page with a search bar on it. This is the most underrated journey in human history. Let us actually look at it. Before we begin, 2 things you should know. First, the entire journey we are about to take, from your keystroke to a fully loaded web page, takes about 200 milliseconds. That is, 0.2 of a second. About the time it takes you to blink. Second, your computer does not actually know what Google.com is. Not really. The word Google is meaningless to it. What it understands is numbers. Long strings of numbers, called IP addresses, that tell the network exactly which machine, in which building, in which city, is supposed to receive the message. So the first thing your computer has to do, before anything else, is translate. It needs to convert Google.com into a number. To do that, it asks a stranger. Inside your operating system is a small piece of software with a quietly extraordinary job. It is called the DNS resolver, and it is the closest thing the internet has to a translator. Your computer hands it a name. The resolver hands back a number, but the resolver almost never knows the answer itself. So it does what librarians have done for centuries. It asks other librarians. The first one it asks is usually a machine at your internet provider. If that machine has looked up Google.com recently, it answers instantly from memory. If it has not, the request keeps climbing. It travels to one of 13 sets of root servers, the foundational machines of the entire internet, distributed deliberately across the planet, so that no single failure can take the whole system down. The root server answers, but only partially. It says, in effect, I do not know about Google.com specifically, but I know who handles all the .com addresses. Try them. Your resolver tries them. The .com server answers, similarly, that it does not know the specific address either, but it knows which servers Google itself maintains for this purpose. It hands over their address. Your resolver, now 3 hops in, finally asks a Google-owned name server. That server hands back a number, an IP address. The translation is complete. Total time elapsed, on a typical fast connection, somewhere between 10 and 40 milliseconds. Your computer now knows where to go. But knowing the address is not the same as being there. The actual message still has to travel. Your request gets broken into packets, small standardized chunks of data, each one stamped with the destination address and a number that says how it fits with the others. These packets do not travel as a group. They split up, sometimes taking entirely different paths across the world, because the network is designed to flow around blockages the way a river does. Most of them will, at some point, travel through fiber optic cable. If you are in Europe asking about a server in the United States, several of those packets will physically leave the continent through an undersea cable, a glass thread lying on the ocean floor, carrying your search query along with petabytes of other data, all encoded as pulses of light. There are about 500 of these cables in the world. Together, they carry roughly 99% of all intercontinental internet traffic. Satellites get the press, the cables do the work. Your packets reach the Google data center. But before any of them can actually deliver their message, your computer and the Google server have to perform a small piece of digital theater that almost nobody talks about. They have to introduce themselves. This is called the 3-way handshake. Your computer says hello. The server says hello back and confirms it received your hello. Your computer then confirms it received the server's reply. 3 messages, in sequence, before a single useful piece of data has been exchanged. It sounds wasteful. It is essential. Without this ritual, there is no way for either machine to know that the other is genuinely listening, that the line is open, or that what comes next will actually arrive. And on top of that handshake, your modern browser adds another one. The cryptographic handshake. Your browser and Google as server exchange tiny mathematical puzzles, prove to each other that they hold matching secret keys, and agree on a code that will scramble every message they send for the rest of the session. Anyone listening between your computer and Google's server, on any cable, in any router, in any country, sees nothing but noise. That tiny padlock icon next to the address bar is doing roughly 20 years of cryptographic mathematics every time you load a new page. You will never see it. It will never let you down. Now, finally, the actual message can be sent. Your request says, in standardized form, please send me the homepage. The Google server replies with a bundle of code, images, fonts, and instructions. Your browser receives it, decodes it, lays it out, and paints it onto the screen. Total time elapsed, from the moment your finger left the Enter key, somewhere between 100 and 300 milliseconds. You see a search bar. Let us stop and count what just happened. A piece of software you do not own translated a name into a number by asking 3 different categories of strangers in a precise order, none of whom knew the full answer. Your message was sliced into fragments, sent through cables that cross ocean floors, possibly traveled through a dozen different countries, and arrived in the correct order at the correct building. 2 machines that have never met performed a 3-step greeting to confirm they were both real, then performed a separate cryptographic ritual to agree on a private language nobody else could understand. A page was assembled, sent back over the same route, decoded, drawn, and shown to you. All of it, end to end, in less time than it takes you to blink. And every step of this was designed by different people, in different decades, often working in different countries, who frequently did not know what the other steps would eventually become. The result is the most complicated machine human beings have ever built. And it is also the only one that nobody is really in charge of. There is no single company that owns the internet. There is no single government that runs it. There is no central control panel where someone can switch it off. There is just a set of agreements, written down in documents most people will never read, that an enormous number of independent machines have voluntarily decided to honor. It is a working anarchy. And every single time you press enter, it succeeds. Most of us have grown up treating the internet the way our grandparents treated electricity. Something that arrives when you flip a switch. Something that just works, and that you only think about when it breaks. It is worth, occasionally, stopping to look at what the switch is actually doing. 200 milliseconds, one typed phrase. A chain of events that crosses continents, passes through encryption, navigates a working anarchy of trust, and lands on your screen as a blank page with a blinking cursor. This used to be considered magic. It is, in fact, much stranger than magic. It is an enormous, distributed, leaderless collaboration that nobody is fully in control of, and it works hundreds of trillions of times a day without anyone noticing. Every part of that sentence is its own story. The cables on the ocean floor, the handful of root servers that anchor the whole system, the mathematics that lets 2 strangers share a secret in public, the companies that quietly hold the parts of the internet that the public has never heard of. Each one is a video we are going to make. Because once you stop taking this for granted, you cannot start again. And that is, in some small way, what this channel is for.